Welcome to this explainer. Okay, so today we're unpacking the 2026 Waterjet Cutting Basics Procurement Guide. Look, if you're a procurement manager, a supply chain pro, or a brand owner, you're definitely going to want to pay close attention to this. We are diving into how the data in this guide positions this specific fabrication tech as a massive tool for shrinking your total cost of ownership, your TCO. We're going to break down the mechanics, the applications, and honestly, the most important part, the hidden costs it helps you completely avoid in your supply chain. Let's get into it.
To kick things off, just consider the sheer raw power at play here. Mach 3. Literally, Waterjet technology takes a high-pressure stream of water, forces it through a tiny jewel orifice, and actually achieves cutting speeds exceeding Mach 3. I mean, we're talking faster than a fighter jet deployed specifically to slice through your manufacturing materials. It's an incredible feat of engineering, and it really sets the stage for the massive supply chain efficiencies we're about to explore.
So here's a quick look at our agenda for today. 1. The Waterjet advantage. 2. Pure versus abrasive cutting. 3. Uncovering hidden TCO savings. 4. Comparing fabrication alternatives. And 5. Vetting your Waterjet supplier.
Let's start right off with Section 1, the Waterjet advantage, power and precision.
The scale we're dealing with here is just staggering. 90,000. Industrial waterjets operate at an astonishing pressure of up to 90,000 psi. To put that into perspective, you know that heavy-duty driveway pressure washer you might use on the weekend? That might hit, 3,000 psi? This tech uses that extreme 90,000 psi stream to precisely erode a narrow line directly into the material. It doesn't hack away with a blade, it doesn't melt through with a laser, it forces microscopic erosion at an incredibly rapid pace. And actually, this cold precision erosion is the absolute fundamental reason why a waterjet behaves so differently than any conventional cutting tool you might have on your factory floor.
Moving right along to Section 2. Pure versus abrasive cutting, know your process. Now, depending on the application, this technology essentially comes in two distinct flavors. First up is pure waterjet, which, you guessed it, literally uses just water. Because it leaves an extremely thin cut or kerf, it's absolutely ideal for soft materials. Think foam, rubber, plastics, gaskets, even food products. It's clean, fast, and super efficient for those substrates. But when you introduce a hard, abrasive grain like garnet into that high-velocity stream, well, then you get abrasive waterjet. Suddenly, you've got the power to slice right through incredibly hard materials. Stainless steel, stone, carbon fiber, heavy aerospace, titanium, you name it. For a procurement manager, understanding this distinction is huge, because depending on the specific process, you can source the fabrication of almost anything on Earth from just one single, highly versatile technology class.
Which brings us to Section 3, uncovering hidden TCO savings, the iceberg model.
Okay, so the biggest hidden cost lurking beneath the surface of any fabrication process is the HAZ, or heat affected zone. This is basically a molecular structural change at the edge of a material, and it's caused by thermal cutting. When you use a laser or plasma cutter, the sheer heat naturally melts the edge of the metal, right? Well, that melting leads to localized hardening, warping, or weakening. And for a procurement manager, dealing with a heat-affected zone is an absolute nightmare for your supply chain. It means you're paying extra for secondary heat treatments or machining just to clean up that edge. That translates to managing a secondary vendor, dealing with complex logistics, increasing transit costs, and significantly extending your overall lead times. But here is the real game changer. Waterjet is a cold cutting process. It completely eliminates the heat-affected zone. So in super strict industries like aerospace or medical manufacturing, where material integrity is literally everything, avoiding those secondary processing steps radically slashes your overall total cost of ownership.
And beyond eliminating heat damage, there are secondary green procurement benefits that just keep chipping away at your TCO. First, think about the work environment. There are absolutely no toxic fumes. Unlike thermal cutting, which creates hazardous vapors and requires, expensive ventilation systems and strict safety compliance, Waterjet produces none of that. That lowers the facility overhead, which is a saving that's very often passed right down to the buyer. Second is tight nesting. Because that cut width is microscopic, you can pack your parts much closer together on the raw material sheet. It's kind of like a giant puzzle. If you're buying crazy expensive aerospace-grade alloys, maximizing your yield per sheet and drastically reducing scrap waste is a massive win for your budget. And third, extreme versatility. A waterjet can literally slice through a 100mm thick plate of steel without breaking a sweat, and it totally ignores the issues laser cutters have with highly reflective metals like copper or brass. One machine handling endless materials with minimal waste? Yeah, that definitely simplifies your entire sourcing strategy. All right, Section 4, comparing fabrication alternatives, the data matrix.
So when you're evaluating trade-offs based on your sourcing KPIs, the data paints a crystal clear picture here. For ultimate precision and speed on thin items, laser cutting definitely holds a slight edge. It's incredibly fast for thin-gauge sheet metal, but laser tops out around a 25mm thickness limit, whereas Waterjet boasts a massive thickness limit of 200mm or more. Plasma cutting can also handle thick metals, but it's strictly limited to conductive ones. The most critical metric for total cost of ownership, though, has to be heat impact. Plasma and laser both carry high to very high heat impacts, which risks that costly heat-affected zone we just talked about. Waterjet stands completely unmatched here with absolutely zero heat impact. It makes it the objective, clear-cut choice for thick, reflective, or temperature-sensitive materials where edge quality is absolutely paramount to your final assembly.
Let's dive into our final section, Section 5, Vetting Your Waterjet Supplier, the 2026 checklist.
Now, to actually secure these advantages, you really need to know who you're talking to in the market. The supplier landscape generally falls into 3 distinct buckets. First, high-end OEM manufacturers. These are the folks you go to if you're bringing production in-house and need the heavy machinery and CapEx solutions to build out your own facility. Second, specialized contract manufacturers. These are your job shops offering cutting as a service. They're the partners who will actually physically make your parts. And third, component and abrasive suppliers who provide the essential daily consumables to keep those machines running, things like garnet, nozzles, and high-pressure seals. Recognizing exactly which of these 3 entities you're negotiating with will instantly streamline your procurement strategy and help you target the right RFQs. Speaking of RFQs, when you're issuing your next one, implementing a strict vetting sequence will guarantee supplier quality and secure the absolute best total cost of ownership. First, verify their tolerance capabilities, especially on thicker materials where precision naturally kind of tends to drop off. Second, specify your surface finish grades. Waterjet finishes range from a Q1 rough cut all the way up to a Q5 smooth finish. Make sure your RFQ specifies the exact Q level you need so you don't accidentally overpay for a perfectly smooth finish when, let's be honest, a rough cut would have done the job just fine. Third, check material verification by asking for MTRs or material test reports to ensure full traceability. Fourth, assess their secondary operations. Can they deburr or top parts in-house? Because that immediately reduces your reliance on sub-vendors. And finally, gauge their lead time management by asking exactly how many cutting heads they have per machine. This single question is brilliant. It reveals their true throughput capacity versus what they might just be promising a new client.
We've covered the sheer speed, the distinct processing types, the immense TCO savings driven by cold cutting, and the precise vetting checklist you're going to need for 2026. Which leaves me with one final provocative question to challenge your current supply chain strategy. Is thermal distortion secretly driving up your manufacturing costs? Take a really close look at your secondary heat treatment bills and your raw material waste logs. It might just be time to reevaluate your fabrication options and see exactly what Waterjet technology can do for your bottom line. Thanks for joining me on this explainer.